So I tell my students to keep this picture in mind of what elastic demand looks like, or to be more precise, a region of the demand curve that's elastic, because it's not quite as obvious when it's like a normal looking demand curve like this, although if we go through it, we can kind of see the change in revenue. But if we exaggerate it a little bit and do a really flat demand curve, then you can clearly see price falls, right? Original revenue here, price times quantity, new revenue here. So I'm going to drop that price, total revenue rises, and that tells me this is elastic in this range. Now remember, straight line demand curve, this would keep going off the screen. The top of this demand curve is elastic, and we're looking at the top of the demand curve. So if I kept going, wherever that midpoint is going to be unit elastic, and then bottom of this demand curve, doesn't matter how flat it is, because remember, it's not slope we're talking about, but the bottom of that demand curve is going to be inelastic. In just the opposite case, draw a really steep demand curve and look at the bottom of that demand curve. So now you can see, just eyeballing it, price at P1 here, price times quantity is whatever that amount is. I'm going to drop the price, and clearly the revenue is falling. Right, so if I can just remember that this is what inelastic demand curve, inelastic demand looks like, I can keep that revenue relationship in mind, and it's easy to remember. So remember, elasticity, what you're measuring is how responsive you are to price. And so a region like this, you can see quantity just isn't responding that much. I'm dropping the price a lot. I'm getting a little more quantity, but not much. So we're not very responsive. This is inelastic demand. However, keep in mind, it doesn't matter how steep this is. If I kept going, the top of this demand curve is going to be elastic. It's just that if I draw a curve like this, I know this I'm going to be looking at the bottom of the demand curve unless I have a really long piece of paper. So this is going to show me this, to be more precise, this is the inelastic range of this demand curve, because again, elasticity is going to change along this demand curve. But I know that in this range, I can tell just by looking at the revenue that in this particular range, it's going to give me inelastic demand. Okay, so for our extreme cases, let's think about, again, what a really flat but still downward sloping demand curve looks like. And remember, what that means is that if I have a little bit of a price change, whether it's higher or lower, I'm going to get a really big quantity response. Right? That's what elastic means. So I'm getting a very big quantity response for just a little bit of a price drop. Right? And let's just go one step further and make it completely flat. So it's sort of a little harder just to get the intuition of what's happening if the price changes, because there's only one price here. So that's why it's useful, I think, to just think about this case. Okay, this gives me a really big quantity response. Well, imagine I had a normal curve and I just started rotating it and towards this, and then I'm just going to keep going, and now I have this. So again, this is the extreme version, where instead of a really large quantity response, this gives you an infinite response. So basically, if that price were to change at all below that price, basically you're just going to infinity. And if the price were to rise above this, you're just going to zero. So again, it's sort of an extreme version of this. And that's elasticity is infinite, because remember, that's what we're looking at here, this ratio. So basically an infinite change here on the in the numerator. And the other extreme would be perfect. So this is perfectly elastic. This would be perfectly inelastic. And again, imagine a really steep demand curve. I'm just getting very little quantity response. And here I'm getting zero quantity response. So it doesn't matter what happens to price. There's going to be zero quantity response. So elasticity is zero in that case. It's perfectly inelastic. So let me just point out that we've been talking about the demand curve. There's not as much to say really about supply elasticity, because the reason we had this kind of issue with the demand curve with changing elasticities is because quantity and price are moving in opposite directions. We don't have that issue with supply curves, right? Supply curves are upward sloping, so more quantity, more revenue. So you're not going to get that changing elasticity going on in the supply curve, but the concept is still the same. It's just how responsive you are to a price change. So if the price changes a lot, then if the quantity changes a lot for a given price change, you would have a relatively flat supply curve, or you could have a relatively steep demand curve where you're not getting much of a quantity response, and that would be inelastic supply. So it's pretty straightforward when we're talking about supply. Let me just mention one more thing about the unit elastic case. We said that we had this relationship between price and revenue. So if price falls, revenue goes up, it's elastic. If price fell and revenue went down, it'd be inelastic. Or price going up and revenue going up is inelastic. So you have to be really comfortable with these relationships again. But look at this case. So we said that if the price changes and revenue stays the same, it's unit elastic. Now we saw that there's a unit elastic point, but how does this happen when revenue is unchanged? So that would happen in a case like this, where suppose we had a price of 8 and then we drop the price all the way down to a price of 2. This revenue is 16 over here, and then I drop the price and the revenue is still at 16. And so the way that happens is if we have a move that's symmetric around this unit elastic point. So these distances would have to be the same in order for that revenue to stay the same. So if we go back to our total revenue graph over here, we are moving here, which corresponds to this point, and then all the way down to here. Well, I did 8, but same idea. So if I did 8, I'd be here, and then I'm just moving over to here. And so it keeps, if I do it across that point is right here at the unit elastic point where it maximizes revenue. If I go across that point, then I'm going to keep revenue unchanged. And so even though the point that I'm starting with and the point that I'm ending with, neither one is unit elastic, so I can't say anything about those particular ranges because this range is elastic, this range is unit elastic, but we would say for this particular change in quantity demanded, this particular change on the demand curve gives me unit elastic demand. So whenever I'm symmetric, here's another case. So anytime I'm symmetric, I'm going to be keeping that revenue the same. So here's revenue of 24. If the price is for this particular demand curve, the price is 6 and the price is 4, it gives me the same revenue. So just have to be a little bit careful. Usually it's clear from the context what a book or someone is talking about demand being unit elastic. So it would have to be some kind of move like this, even though there's only one point that's unit elastic. So again, in terms of our formula, that one's supply. Just any time those percentages end up being the same. So 10% change in quantity as a result of a 10% change in price, then that's going to give me unit elastic. But by the way, I should mention if we do the change, this ratio is going to end up being negative because the quantity and price move in opposite directions, but it's standard to just use the absolute value and just to call it a positive number. Because when we're talking about demand elasticity, it's implied that we're talking about a downward sloping demand curve, which we know is going to be negative, and so we can just leave out the negative sign. So if we had a case like this that wasn't symmetric, so here we're going from 9 to 4, and obviously the revenue here is going up. It's going from 9 to 24. So just the change in revenue is telling me that this particular move is showing me elastic demand. So that change we would call elastic. That change in quantity demanded. So if you have revenue information, that's the easiest way to just do an elasticity test instead of actually calculating it. Although if you were given numbers, you might have to do a percentage calculation. So just to sum up, to be really clear about the relationships that are going on here between revenue, price, quantity, and revenue, I like to keep this picture in mind, this relationship between price and quantity, total revenue on our demand curve. And then I also tell my students again to keep these two pictures in mind. So this is sort of a more obvious picture of what elastic demand looks like clearly, as long as I can remember that this is elastic, this highly responsive quantity to a price change. Then this being elastic means that when the price falls, revenue goes up, or when the price rises, the revenue goes down. And this would be a case of inelastic demand, where clearly you can just eyeball the revenue change. If that price falls, then revenue goes down, price goes up, revenue goes up. So being relatively unresponsive to a price change is inelastic demand.